Your car windows started like this: sand, limestone and dolomite to stabilize the chemical reaction, soda ash to lower the melting temperature, and broken glass or cullet to help the melting. A continuous ribbon of molten glass is floated on liquid tin before being cut into flat pieces. A computer-controlled tungsten carbide wheel scores the required shape of your car window, and a flame creates thermal stress to crack it along the score. The edges are then ground and washed. This particular glass is set to be toughened by being floated on hot gas.
It's toughened by heating ordinary window glass to around 630 degrees centigrade and chilling very rapidly, which puts a surface compressive stress into the glass, making it very strong to massive impact. That's obviously a benefit. The stress is built into the glass by that process. If it is released by the layer being penetrated by a sharp object, it causes the glass to shatter into tiny fragments, causing not too much injury. Laminated glass, on the other hand, is ordinary window glass, but it is given its safety by the incorporation of an interlayer, these days, of PVB, or polyvinyl butyral, which is a very stretchy material, so that if you do have the misfortune to hit it with your head, acts as a safety net and stops you from being ejected from the car. Less important now, of course, because seatbelt legislation and airbags do tend to stop people hitting the windscreens anyway.
Glass to make laminated windscreens is much thinner than your other car glass. Alternate glasses are cut as inners and outers, one slightly bigger than the other to compensate for the difference in curvature when stuck together with the plastic sandwich. The glasses are curved as a pair using a sag bending process, where at 600 degrees Celsius they bend under their own weight into a mold. The thin plastic interlayer is added in between the two pieces of glass, and the package is squeezed together before being baked in a high-pressure furnace or autoclave for 1.5 hours. Each panel is then checked for quality under special lighting conditions. But maybe you don't really care how your car glass is made. You just want to know what it can do for you.
We've got this set up here, but we've actually used it as a demonstration to go out to car manufacturers and show the stylists and engineers of the future. What we've actually got is a windscreen. First of all, it's got the heated windscreen in it. Secondly, at the top of the glass you'll see that there is a raindrop sensor. This means that during rainy conditions the windscreen wipers will automatically activate, and we can set that to a number of levels for intermittent wipe or continuous, etc. Also in the windscreen, looking from the inside of the car, you can see a head-up display. Obviously this is something very much for the future, but you could see a number of your instrument controls projected onto the windscreen as you're actually driving. So very simply the demonstration here shows the speed the car is going. That system has also been used extensively in a European research project to actually drive a car in night conditions or in very foggy conditions, and we've actually done tests and trials of actually driving a Jaguar car in complete darkness for the police.
What, you mean with no headlights on?
With no headlights on at all, just complete darkness.
How do you see then? Is it an infrared camera?
It's an infrared system that displays an image then onto the head-up display.
Wow.
in the car. It's a very, very impressive system. Obviously, again, it's not going to be for the general public in the foreseeable future, but it could be used in the military or in the police type activities. Moving around the car, we've got then laminated side glazing. Here we also show that you can put heated wire elements to demist or defrost the side glasses. Also on the same side of the car we've got the double glazing. This again is used in many of the top of range vehicles. That gives extra noise and heat performance. Around the back of the car there's various examples of antenna systems. These are printed circuits onto the glass for either telephone or even TV antenna systems.
But car glass need not just be practical, it can be beautiful as well. Triplex are consultants to the young car designers at London's Royal College of Art.
Well, yes, we've been involved with the Royal College of Art now for the last 9 years. Our main purpose is to help with the innovative designs of glass styling and help students actually understand what can be done or can't be done with glass, and also to build long-term relationships with the potential stylists of the future.
This year's winner of the Design Awards competition was Matthew Bevan and a two-seater sports leisure vehicle. His astonishing college-made 3D animation of his vehicle rivals the quality of some top manufacturers.